So I do have the handouts, for you to keep, not for homework or any kind of extra work you do. But I do type up everything so then later you can refer to, in case when you need some help, in my quiz. So you do have access to the handouts about the factoring. But I do want to demonstrate 3 more problems. The numbers are getting a bit bigger, and also you might have some subtlety to deal with when you have some GCF to take care of, right? But we are factoring trinomials when the coefficient of the quadratic term is not trivial. We're going to use the slide divide. I already demonstrated how it works out, but with the easy numbers. So let me do those 3 letters. Now, that's not from the packet 1.5, right? Yeah, that's why I said on your way out, you pick up a package. Everything's typed up. I just want to explain to you how that works out so then it'll be easier for you to read. But of course, if you're fine with the method, that's just, some reference, in case you need it or you want to know like what I'm talking about. Anyway, but typically, this is not what we're supposed to do because, factoring is supposed to be covered before the college algebra, right? Because remember I said, but think about this. This is real college algebra, right? Why are we still working on factoring? Anyway, let's see. Letter A, we have this 12, right, as a non-trivial leading coefficient. I'm going to slide it over and let it multiply with, that -2. So you should be better off factoring x squared without that 12, since it's slide over, minus 5x minus -2 times 4, -2 times 12, -24. All right, so now you need to think what 2 factors of 12, what 2 factors of -24 add up to -5. Now, numbers are not too big sometimes, so then, you can probably see right away. But if it's getting bigger, maybe try going through, all the pairs and always start with the easy ones. 24, you can do 1 and 24. 2 and a 12. Right? Of course, you can always do 1 and the number itself, right? But this number is even. That's why I also want to try the 2, right? But always keep in mind, your goal is to get a positive and a negative factor add up to be -5. That means they shouldn't be that far from each other. 24 has a 3, right? And 24 has a 4. And of course, it doesn't have a 5. You end up getting 6 and a 4, but you know that it won't make any difference, right? Because all we need is a pair of factors. The order doesn't really matter. A fun fact. Have you guys heard of a card game called Game 24? We've heard of it, or we've never heard of it. Anyway, it's a game. You can maybe look up around the App Store. It's basically 4 cards. Well, of course, poker, right? Poker cards, they have 1 to 10, right? Then Jack's 11, Queen is 12, King is 13. So 2 players, right? One has a deck of cards. So each player plays 2 cards on the table. So then you have 4 cards. Then both player has to figure it out. So only using addition, subtraction, multiplication, division. No square root, no factorial, right? No fancy, methods. Using those 4 numbers to get 24. Okay, and whoever gets, the answer quicker, right, wins that round, and just keep going until they figure out a win. But do you know that why they came up with the game 24, not game 36, not game 81, right? So 2 cards, right, from 1 to 13. Why they pick 24? Because 24 turns out to be a number that has many factors and it's not too big. And that's one of the reasons behind it, right? Because you see that how many numbers, how many factors, how many possibilities of getting a 24 out of 4 numbers. Okay. Anyway, now another concern sometimes students might have is, well, if you have a negative number, I know one of those numbers has to be negative, right? But the reason why I'm not putting the negative signs right away is I want to be flexible. I want to see that when I pretty much settle with a pair, right? Because I know that these 2 numbers are exactly 5 units apart. So I need to figure it out. Should I go with -3, 8, or 3, -8? Well, in this case, it will be +3 and -8 because I want them to add to be -5, right? If you start putting down negative numbers, then you're going to have 1, 24, well, -1, 24, 1, -24, just too many options, right? Settle with a pair, then you're going to think about the negative signs. That will probably save you some work. Anyway, so we see that here, after doing a sliding, we can factor this trivial case with x minus 3, or actually plus 3, right? X minus 8. So then you're going to do the divide. You're going to divide out the same constant, the same number that you slide over in the first place. Okay, so divide both numbers by this number you slide over, and simplify the fractions as much as you can. So 3 over 12 is 1/4. 8 over 12 is 2/3. Right? So if you're not able to simplify it to an integer, then make sure that you swing up the denominator and put it in front of x. So you're getting 4x plus 1, 3x minus 2. Okay? And let me box this to make sure that you know this is the correct and ultimate form of the factoring for the original trinomial. Now, even though I'm a big fan of the slide divide, I know that people using grouping, right? But I do hate the work that I have to put down for the slide divide because it's not the kind of a traditional algebra. Now, the reason why I said that is you see that I do not want to use the equal sign as I go from here to there because they are not equal. It's just that so people figure that by effectively developing a mnemonic called slide divide, it works out perfectly. But obviously, if you try to put down the work, it's most likely for you to memorize how it works out. It's not something they want to show your instructor. That's why I boxed the answer, and I want to let you know that this is the correct factoring. Don't get too crazy about whatever I put down, as long as you understand what I'm saying. All right, letter B. We'll do the same thing, right? Slide over to 8, GP factoring y squared plus 13y minus 48. Now, let me give you maybe 10, 15 seconds or something like that to think about, or maybe going through those many pair of factors of -48 in your mind. See if you can figure out what pair of 2 factors add up to be 13. Oh, you got it already? What is it? 16 and a 3. And you make the 3 negative since you want a positive 13, right? Good. So I believe that, either you're just used to this way of thinking about factors, right? And always keep up the sum, or, just by trying something I did on the board, right? Try not to spoil you anymore, like writing things down. You will get quick, okay? But thanks for that. Y minus 3, y plus 16, right? But don't forget slide. Now divide y minus 3 over, what number I slide over? Okay, 8. Y plus 16 over 8, right? Now 3 over 8 does not simplify at all. I'll swing up the 8 and put it in front of y. So 8y minus 3. 16 over 8 does simplify to an integer. Just keep it as is. Okay. All right. The last one. The reason I'm keeping the letter C, or let's just see what's going on with letter C, is because you see sometimes you will have to take out a GCF, or you don't have to, but you're better off to do that, so then the numbers get smaller, so then the process of the slide divide, or whatever you want to use to factor trinomials, will be more efficient. So let's identify what the GCMF greatest common monomial factor is for 3 terms over here. Now, first off, as you scan through the numbers, 20, 34, and 6, they're all even numbers, right? So I guess that your best bet will be at least a factor 2. But it turns out that that's the best you can do. Right? They all share a factor 2, no more. Now, when it comes to the variables, they all have x in it. But the best you can do is x to the first power, right? So 2x is a GCMF. But now the problem is people don't like the leading coefficient as a negative number. Typically, not always, but you might want to try factor out a negative GCF, and that's what I'm going to do for letter C. See what's going to happen to the trinomial if I factor out negative 2x. All right, so now the first term, take out a negative sign, take out a 2, take out an x, you're left with 10x squared. The second term, it was positive. Take out a negative, GCF, you get negative 17, right? 34 divided by 2, 17. X. The last term, it was negative. Now it becomes positive 3. Okay. You can always do a sanity check by, redistributing the negative 2x into, the trinomial. Now I'll put dot, dot, dot. You know that after the slide divide, right? We're going to focus on the quadratic part. You will get, let me tell you what it is. (5x minus 1), negative 2x, 5x minus 1, and 2x minus 3. Okay. All right, so let me zoom out a little bit. Again, on your way out, once you pick up the packet, the handouts, the 2 of them, one for factoring trinomial, the other for binomials, you will have everything that I showed you typed up, nicely on the handout, right? But at this moment, any questions about this process of factoring trinomials? And please understand, it just so happened that I go with the slide divide, right, or AC method. You're not obligated to do exactly like I did when it comes to factoring. I know that, you were told that maybe break up the middle term, right, and do a grouping thing, right? If that's what you do to factor trinomials, perfect, right? Do that in the test, you'll be fine. Okay. All right. All right. So if you guys are okay with the factoring, then let's move on to the so-called square root property for solving quadratic equations. So now we're back to the 1.5 packet, right? If you want one, I have a few extra copies. Right? Only for this time, because I don't know how many students I'm getting. All right. Now, please make sure that you take a close look at the equation before you solve it. If you realize the equation is written in such a form, you have something unknown raised to the second power and is equal to a constant, then you shouldn't do anything other than just taking a square root right away, right? But in letter A, it doesn't seem that it's ready, or at least that it's almost ready. So you do have to do some very basic algebra, right, to isolate that quadratic part so you can take the square root. So in letter A, let's go ahead and add the 15 on both sides. You have 3x squared equals to 15, right? Divide over 3, and you have this square or quadratic part completely isolated. So now to isolate the x, you take the square root but make sure that you are open to both possibilities, right? So positive or negative radical 5, they're both solutions. Okay, so that's probably the only catch, for the square root property. Okay. Now in letter B, you see that it's pretty much the same thing, right? So if you quickly isolate the x squared, you get 9x equals negative 25. X squared is equal to negative 25 over 3. And they go ahead and take the square root. But there's an issue, right? So you have a negative number on the radical sign, right? Or you're looking for a square root of a negative number. Yes. Oh, 9. Thank you. Good catch. Now we did talk about radicals in a summer experience, but we didn't get to the negative radicand, right? So it's actually pretty easy to deal with, radical of a negative number. All right, so I'll just put a little side note there. So square root of x is nothing but square root of absolute value of x multiplying the I if x is negative. Okay. That means there's nothing to be scared of a negative number on a radical, because you're going to exchange that negative sign on a radical for an I, which by the way is an imaginary number, outside the radical. And it's multiplying that radical, just so you know. Right? That's why sometimes I put a dot, remind you that it is multiplication. All right, so now what do I do here? I will do square root of 25 over 9. It's not negative anymore, but the cause is to have an I, right? Multiplying the radical. Now, simplifying radical has been covered in the summer experience, or maybe in the past. So radical of 25 over 9 is nothing but 5/3, right? Yeah. Now, if this is a test problem, right, an FRQ, and I leave the answer like that, would I get full credits? Okay, what's wrong with it? Thank you. There's no plus or minus, right? And that's why you see that I did leave some space. Hopefully you did that, so you can squeeze in the plus or minus. You don't have to do different colors, but just remember that for any quadratic equation, you must have two solutions. I didn't say they're real. I didn't say they have to be different, but you must have two. Okay. no need to really worry about the I at this moment. We're not doing anything crazy about imaginary numbers. It's just that you need to know when you have to introduce the I, and this is pretty much the only moment, right? So you have a negative number on the radical side. All right, letter C. So I hope that you don't end up being expanding the left-hand side, forwarding it, so you get a trinomial, and you take that 3 off the right-hand side. You end up being dealing with a quadratic equation in a general form. I know that everyone knows the quadratic formula, right? And that's why you have the confidence to move on. But it could have been a lot shorter process if you realize, I mean, you could still take the square root property right off the bat. You just have to make sure that you put in the plus or minus, right? The two possibilities. So that square root is going to kill that the square. So you get x minus 2, right, equals to plus or minus radical 3. By adding the 2, you will get plus or minus radical 3 plus 2, right? Or sometimes I feel like that it will be prettier if you put the 2 in front, right? Because, you know, order of addition doesn't matter. So it'll be 2 plus or minus radical 3, right? But either way, but you are getting two solutions, right? One go with a plus, the other go with a minus. Okay. All right. Now, so far so good. Any question about the square root property? You're good, right? It's just, you know, sometimes you have to do the imaginary number, right? But nothing too crazy. Now, what if we're getting pretty much like a general quadratic equation? It's not guaranteed to be factorable, and it's not written in such a form that you can just do a few rounds of simple algebra, you get into something you can take a square root right away. But it turns out that we can brutally force that equation to be written as if a perfect square. So you can still take the square root. Therefore, we're learning a technique called completing the square. Okay. Now, let's try that. Right? You know, if you feel like reading, because I'm sure that you've learned it before, let's just try that with a simple example. And later on, we'll see that what kind of subtlety we'll have to deal with if you do have a non-trivial quadratic coefficient, right? But you'll see that it's pretty, you know, easy to follow, you know, the routine when it comes to completing a square, okay? But here's a little trick, I'm sure that you know. I just want to put it on a board so then you can think about doing it when you complete the square. All right, so let's say we have x squared minus 2x. So only the quadratic and the linear term. By completing the square, I mean, I need to come up with a term, usually is a constant, add it to those two guys. So then you have a trinomial, which could be factored as a perfect square. And it turns out that the structure of whatever things you're going to add it to those two guys is always the square of half of the linear coefficient. So whatever that number is in front of x, take that negative sign as part of the 2. You just divide that negative 2 by 2. Okay? So half of the linear coefficient. You might say, why am I not taking the square of it? Because it could be as simple as -1 squared, which is 1. Because I don't even care what this number is. What I want to know is, how does it factor? Right? Because I want to have a perfect square. And I know that it has to factor in such a way that it's going to start from x. Well, the reason we start from x is you're dealing with x. It could be y, right? Or other things. And what goes in here is the half of the linear coefficient. And that's why I don't even bother to square it. All I need is what's negative 2 over 2? Negative 1. Okay? So that's the process of computing the square. Always add the square of half of the linear coefficient. And you're going to factor it as x with whatever number that you have inside the parentheses before you square it. Either add it to the x or subtract it from x. That's all. Okay. So go with the sign here. So now let's do it over here. We have x squared minus 6x, right? Well, you see that I don't need any extra constants to start with because I'm going to figure out that constant to complete the square, right? Let's get rid of that 4. And you can do that by simply subtracting it off from both sides. Right, so you're going to get negative 4 on the right-hand side of the equation. Right, subtracting 4 on both sides. All right, so now, remember that. Always add. Oh, can you give the door for me? The square of half of the linear coefficient. Linear coefficient is negative 6, right? Divide that by 2, or take 1/2 of negative 6. But this is an equation, right? When you add something on one side, make sure you add the same thing on the other side just to balance it out. Okay. Now on the left-hand side, you are guaranteed a perfect trinomial. All I have to do is put that in a perfect square form. Right, so it's going to start with an x, but what goes in here? What do you think? According to that little example on the board, negative 3, right? Not square of negative 3, just negative 3. Let me highlight that. It is the number before you square that enters the perfect square at the end. Now, on the right-hand side, just a whole bunch of numbers. You do have to work it out. Negative 4 plus, this is negative 3 squared, so it'll be 9, right? So you get a 5. And now x minus 3 squared is 5. And therefore, you should take the square root right away without expanding it. X minus 3 is plus or minus radical 5. And isolating x, you get 3 plus or minus radical 5. Okay? So it's pretty much still using the square root property, right? We have to massage that equation in a way, and it's ready to be taken the square root, right? And that little trick, will always work out as long as you have a trivial leading coefficient. Okay. Now, how about we do letter B? And we'll try to work it out almost the same way as letter A. But we do have to deal with that fact of 9, right? So again, I'm still going to start with just the quadratic term and a linear term. And I'll take that 4 to the right-hand side, so it becomes negative 4, so positive 4. Well, thanks to the fact that we have an equation. If you see that the coefficient is 1, that will work out perfectly. You have a way to get rid of that coefficient just by dividing it out across the board. Okay, so we'll be looking at x squared minus 6 over 9 x, leave some space, 4 over 9. So now, who can tell me that constant I need to add to the left-hand side and also the right-hand side as well to complete the square? What should I add here? Go with the pattern. It's always the square of half of this guy, right? But what is half of negative 6 over 9? You can either try that in a calculator or write it out, right? 1/2 times -6/9, -1/6, right? Oh wait, 1/3. This is 2/3, right? -1/3. So literally half of the linear coefficient. You guys get that? I got a -1/3, and that will be the number here. And make sure that you're going to balance out the equation by adding the square root of -1/3 on the other side. So when it comes to factoring on the left-hand side, no need to really overthink it. You guaranteed x minus 1/3 because it is that constant, which is half of the linear coefficient that enters the perfect square. All right, on the right-hand side, it is 4/9 plus 1/9, that is 5/9, right? After you're taking the square root, you get x minus 1/3, right? And that will be plus or minus radical 5/3, right? Because square root of 9 is 3, and therefore you end up being looking at 1/3. Oops. Plus or minus radical 5/3. Okay, and there we have it.